All right. Yesterday, we worked on graphing ordered pairs on a coordinate plane, and we even used a coordinate grid with the 4 quadrants. Remember our 4 quadrants from yesterday? One thing I didn't mention from yesterday is these 4 quadrants actually have a name. The one that we started in was quadrant 1 because those are the ones that have both positives. But then they kind of go around in a clockwise circle. 2, 3, and 4. Now, not that you really need to know those today, but they are good knowledge. Okay, so today it's important for you to know how to graph those ordered pairs, Darius. And it's also important to know how to solve a linear equation, which is an equation like we've done in the past, nothing too different. So how do we graph an equation on a coordinate grid? Well, this girl, she can walk 3 miles in 1 hour. Now, if she goes that speed, how far could she walk in 7 hours? Well, if we look at the map, we can also kind of look for a pattern. Observing a pattern helps us to answer the problem because we can kind of predict the results that way. So an equation whose graph is a straight line is called a linear equation. Do you see the word line in there? Yeah, so we definitely need it to be a straight line. Now let's solve this problem. So we're going to write an equation and then we're going to graph it on a grid. So what would be an equation that would express Amy walks 3 miles in 1 hour? Amy walks 3 miles in 1 hour. Well, we want 3 times the number of hours, right? Why are we going to multiply? Because our number is going to get bigger. We know how far Amy walked in 1 hour, so we want to find how far she'll walk in 7 hours. To write the equation the shortest way possible, let's let the letter x be the number of miles, and we'll let the letter y be the number of hours. So it'll take her this many hours to do it, 3 times this number. So if we make a table, like an input-output table like we've been good at doing before, we'll be able to figure this out. Now, they put in a 1 for 1 hour, 3 miles. They also had shown a pattern of if it was 3 miles, it would be 9 hours. If it's 5 hours, it'll be, 5 miles, it'll be 15 hours. So if we made one more, what would our next number be? 7. So that's the magic number we're looking for, 7 miles. Do you guys see a rule from x to from x to y? What's the rule? Darius says the rule is multiply by 3. So what would our y be if our x is 7? 21. Now we can actually take all of these numbers and we can plot them on one of these. Yeah, we can do that. But today we might want to make one that looks a little more like this because I don't think we're going to have any positives or negatives today. So if we have something that looks like this, we can go back now and we can plot 1 and 3. 1 over 1 up 3. What was our next one? Do you remember? 3 and 9 over, starting at our origin, over 3 up 9 over 5 up 15. Of course, yep, we're going to run out of space here. But you're going to notice, well, it would be higher than that, that if you connected these dots, they're going to make a straight line. That's right. If they don't make a straight line, we've got a pretty big problem. It means we did something wrong. So let's make some of these today. Let's try some. Now, I'm going to pause for a minute and I'm going to hand out the materials you're going to need. So now everybody has in front of them a blank grid and some blank input-output tables. So let's take a look at some practice ones that we can do together. The first one, I want your pencils down, and I'm going to do this one up here for you to watch with me. So if I have a blank input-output table, I have the x-axis, the y-axis, and I made 2 extra actually there. You may have to move because I don't know how much I can really move myself. We're going to find the value of y if we use a 2, a 4, and a 6 for the letter x. Okay? So let's put in 2 for the letter x. If we put in 2 for the letter x, what would y equal? Kiara? I want you to take this 2 and I want you to put it in place of the x. Okay? Aiden, I want you to put a 4 in place of the x. What would the y become? I would like you, Emma, to put a 6 in place of the x. What would the y become? Let's do one more. Let's do
26.
Well, let's do 8. America? Okay. So now that we have our input-output table filled out, now we can graph these ordered pairs. So can somebody help me with remember these? Yeah. Okay. So the first one was, so I will start at my origin, over 2, up 5. Start at the origin, over 4, up 7. Start at the origin, over 6, up 9, you said? Over 8, up 11. Now, what you're going to do today is you're going to use the edge of your math journal, but I am going to just pretend that I have a straight edge, which I don't, but let's just pretend. And I'm going to connect my dots, and you should see a straight line. Now, you could put an arrow at both ends because it would go on forever. That's right. If we continued to do this, it would. And if we ended up using negative numbers, it would go down into the other quadrants. Okay? So now it's your turn to do this. So grab your materials and let's try the next one. Okay, so let's put in the numbers that they tell us up here. For x, we're going to use a 2, a 4, a 6. Hey, let's use an 8 too, as long as we have extra space. Okay, so you're going to take this number, this one right here, put it in place of the x, and what now does the y become? Raise your hand if you want to share. Sarah? Substitute 4 for the x. Cole? Substitute 6 for the x. And Will, substitute 8 for the x.
16.
You did not have to look at the wall for that. You silly boy. Now, we can graph these 4 sets of ordered pairs onto your grid. You have to use the same color for all 4 dots, then connect them with the same color that's in your hand. I think yours is larger than mine, isn't it? That's actually not going to work for me to plot the last one because mine's not as large as yours. I can only plot 3. You guys are going to have to eyeball the last one because you don't have a 16 on your grid, do you? Yeah, yeah. Okay, once you have plotted all of your dots, then you need to use the edge of your math journal, lay it flat, and connect them. Don't use a freehand like I am. You need a straight edge to connect your dots. And you should see a straight line. This is called a linear equation. A linear equation makes a straight line. Try to focus, Sarah. How'd it go? Okay, now you guys are going to switch pens. You're going to pass your colored pencil one to the right. So you will not have the same color. You should not have the same color. Okay, grab your input-output table and let's go to our next equation. Okay, here we go. Let's put the same numbers in, 2, 4, 6, and 8, but our y numbers are now going to be different. Who can help me solve for the first one? If I put a 2 in place of the x, what will the y become? Darius? It would become a 1. If I put a 4 in place of the x, Eileen, what would the y become? If I put a 6 in place of the x, Kaden? And if I put an 8 in place of the x, Natasha? Now it's our job to go back and graph with a different colored pencil, the one that's in your hand now, these 4 ordered pairs. No, they're not negatives, Natasha, so you can't graph them in the negative quadrant. You're going to be in the same exact quadrant. This is what you all have, correct? Mm-hmm. Yours goes all the way up to 15. Starting at the origin, up over 2, up 1. And this is what yours should look like, with a straighter line than Mrs. Wager's. Now, if we would extend our line, check this out. It would go into a different quadrant. Okay, so if I would have substituted some negative integers back, that would have made a difference. We haven't really talked much about adding and subtracting negative integers, so we're not going to go that far today. All right, let's do another example. Switch colors again. Okay, I am changing the numbers a little bit here. I'm going to go 2, 3, 4, and 5. Let's not do 5 because 5 is going to be too much. Just 2, 3, and 4. That's good enough. Who can help me out with these? Sarah.